Welcome to a slow, beginner-friendly lesson on HTTP, the rules of web requests, made for absolute beginners. The network chapter continues. Today you meet HTTP, the set of rules every web request follows. Last lesson you learned the idea of an API, a client asks, a server answers. But how exactly does the asking happen? What shape does the request take? How does the server signal success or failure? That is what HTTP defines. HTTP stands for Hypertext Transfer Protocol, but the full name matters less than the four ideas inside it: methods, status codes, headers, and the parts of a URL. Today you learn all four at a beginner level. No code yet, just the rules. Once these rules are clear, writing real Python that calls APIs becomes almost easy. From idea to rules. Last lesson we built the concept. An API is a meeting point where one program asks another for data. Today we go one level deeper. We look at the actual rules that govern how the asking and answering happen. Those rules have a name, HTTP. Almost every API on the web uses HTTP under the hood, so learning these four ideas once pays off for the rest of your career. We stay at the concept level this lesson. Real Python code arrives in the next one. Hold the rules first, the code will feel obvious once they are clear. Rules first, code next. Every conversation needs rules. Who speaks first, what words mean, how to say yes or no. Web requests are no different, they follow a set of rules called HTTP. Every conversation has rules. Let us unpack the name, because each word teaches something. Hypertext means linked text, the kind of document the web was originally built for, where one page links to another. Transfer means moving something from one place to another, here, moving data from server to client. Protocol means a set of agreed rules, like a diplomatic protocol that says who speaks first and how to address each other. Put it together, HTTP is the set of rules for moving data between a client and a server. That is all the name means. The rules themselves are simple. Unpack the name. Every HTTP request has the same four parts. First, a method, a verb that says what you want to do: read, create, update, or delete. Second, a URL, the address that says where to do it. Third, headers, small key value pairs that carry extra information, like what format you are sending or who you are. Fourth, an optional body, the actual data you are sending, used when you create or update something. Not every request has a body. But every request has a method, a URL, and headers. Learn these four parts once, you will see them forever. Four parts, every time. Every request carries four things: a method, an address, some headers, and sometimes a body. Learn these four parts once, and every API you meet becomes familiar. Four compartments, one envelope. A URL looks like one long string, but it has parts. Let us break one apart. Scheme comes first, HTTP or HTTPS, which is the secure version. Then the host, the server's name, like api.example.com. Then the path, what resource you want, like /user/ada. Then, optionally, a query string, extra parameters after a question mark, like city equals Amsterdam. Each part tells the server something specific. The scheme says how to connect. The host says which server. The path says which resource. The query refines the request with details. An address with parts. Look at this URL broken into parts. Scheme is HTTPS, the secure version of HTTP, which encrypts the conversation. Host is api.example.com, the server's name on the internet. Path is /user/ada, which specific resource you want. Query string is city equals Amsterdam, extra details after the question mark. When you write Python that calls an API, you will pass the host and path as the URL, and often pass the query string separately as parameters. But underneath, they all join into one address. Each part has a job. A URL is just an address with parts. Scheme, host, path, query. Each part tells the server something specific about what you want. The address bar of the web. HTTP gives you four main methods. Think of them as verbs. GET means read or fetch, you want data, you are not changing anything. POST means create, you are sending data to make something new, like a new user account. PUT means update, you are changing something that already exists. DELETE means remove, you want something gone. Most beginner API work is GET, fetching data, reading responses. The other three matter when you start building tools that create or modify things. For now, hold the four verbs: read, create, update, delete. Four verbs. Here are the four methods in shape. GET/user/ada, fetch Ada's profile, change nothing. POST/users with a body containing a name and age, create a new user. PUT/users/ADA with a body containing a new age, update ADA's profile. DELETE/users/ADA, remove ADA's account. Notice that GET and DELETE have no body, there is nothing to send. POST and PUT carry a body, because they are sending data to create or change. This pattern repeats across almost every API you will ever meet. Read, create, update, delete. Every HTTP response begins with a 3-digit number called a status code. That number is the server's way of telling you what happened. Did the request work? Did you ask for something that does not exist? Did the server crash? The status code answers before you even look at the data. You do not need to memorize dozens of codes, you just need to know the families. The first digit of the number tells you which family you are in. That single digit tells you whether to celebrate, redirect, fix your request, or pity the server. The server's signal. Status codes are grouped into families by their first digit. 200 codes mean success, the request worked, here is your data. 200 OK is the most common one you will see. 300 codes mean redirect, the resource moved, look somewhere else. 400 codes mean client error, you, the caller, did something wrong. 404 not found is the famous one, you asked for something that does not exist. 500 codes mean server error, the server had a problem on its side. Your request was fine, the server broke. The first digit matters, every response carries a 3-digit number. That number tells you whether the request worked, whether you asked for the wrong thing, or whether the server had a problem. One number, one story. Here are the status codes you will meet most often. 200 OK, success, the data you asked for is in the response. 201 created, success, and something new was made, common after APOST. 404 not found, you asked for a resource that does not exist. 500 server error, the server had a problem, your request was fine. A simple rule of thumb, 200 codes are good, 400 codes mean you made a mistake, 500 codes mean the server made a mistake. When you write Python later, you will check the status code before trusting the data. Good, your fault, their fault. Headers are small key value pairs attached to a request or response. Think of them as labels on an envelope, they carry extra information about what is inside, without being the content itself. The most common header is content type, it tells the other side what format the body is in, like JSON or plain text. Another common one is authorization, it proves who you are, often with a token or key. Both sides use headers. Your client sends headers to describe the request. The server sends headers back to describe the response. You will rarely need to set many headers as a beginner, but you should know they exist and what they are for. Labels on the envelope. Here is what headers look like. Each one is a key, a colon, and a value. On the request side, content type tells the server you are sending JSON. Authorization carries a bearer token to prove who you are. Accept tells the server you want JSON back. On the response side, the server sends content type to confirm the format, content length to say how many bytes the body has, and the date the response was sent. When you use Python's requests library later, you will pass headers as a dictionary, keys and values, exactly like you see here. Key, colon, value. Headers are the labels on the envelope. They carry extra information, what format the body is in, who is asking, how to authenticate. Small keys, big meaning. Small keys, big meaning. The body is where the actual data lives. On the request side, the body carries data you are sending, used mainly with POST and PUT, when you are creating or updating something. A GET request usually has no body, because you are just asking, not sending. On the response side, the body carries the data the server returns to you, the weather, the user profile, the list of products. The format of the body is always declared in the content type header, so both sides know how to read it. For modern APIs, that format is almost always JSON. Where the data lives. Here is a complete POST request with a body, and the response that comes back. The request sends content type application JSON, then a JSON body with a name and age, the data needed to create a user. The server responds with status 201 created, its own content type header, and a JSON body containing the new user, complete with an id assigned by the server. Look at how structured this is. Method, URL, headers, body on the way in. Status, headers, body on the way out. That is HTTP in full. Everything else is variation on this shape. JSON is the modern default. Let us gather everything into one picture. A request is built from a method, a URL, headers, and an optional body. The server receives it, does some work, and sends back a response made of a status code, headers, and an optional body. That back and forth, request out, response back, is the whole of HTTP. Every web page you visit, every API call you make, every form you submit follows this exact cycle. Once you can see it, the internet stops feeling like magic and starts feeling like mail. You send a letter. You get a letter back. The rules are simple. The power comes from doing it at scale. The full cycle, quick self-check. Can you name the 4 parts of every HTTP request? Can you list the 4 main methods and what each one does? Can you say which status code family means success, which means your mistake, and which means the server broke? Can you explain the difference between a header and a body? If any of these feels shaky, rewatch the matching part. You do not need to write code yet, just hold the 4 ideas firmly before we add Python next lesson. Say each out loud. HTTP is the set of rules every web request follows. A request carries a method, what to do, a URL, where to do it, headers, extra information, and an optional body, the data you send. The server responds with a status code that tells you what happened, its own headers, and an optional body containing the data you asked for. 4 methods, 4 status families, 1 consistent shape. That is HTTP. Every API you call for the rest of your career uses these same rules, and the next lesson turns them into real Python. The whole of HTTP, in one breath. Now that you know the rules, the next lesson turns them into running code. You will install a Python library called requests, using UV, the tool you learned earlier in the course. No project setup needed. You will write your first real GET request, send it to a live server, and read the status code, the text, and the JSON that comes back. You will watch HTTP happen right in your terminal. Everything you learned today becomes visible, concrete, and yours. Rules become code. Read this request out loud and test yourself. What method is being used, and what does that method do? What path on the server is being targeted? Which header proves who the caller is? Look for authorization. What format is the body in? Look at content type. If you can answer POST to create something new, the path/products, the authorization header with a bearer token, and JSON is the format, then the 4 parts of HTTP are yours. The next lesson turns this shape into running Python. Decode the request. Thanks for learning the rules of HTTP. Next we write our first real API call in Python. The network chapter continues.